Okay, so now we're on the second part. We are going to rationalize the denominator. And remember last class there were some questions about like why are we doing this? Rationalizing the denominator is a convention that we leave. That's kind of a mathematical convention. Um, Final answers, we recognize different patterns when the radical is not in the denominator. So we have to know how to get rid of it. When we use special right triangles in probably next class, it will be helpful to have everything rationalized because we'll be looking at similar patterns. So that's the why behind this. Ultimately, what it means is no radical in the denominator. So here's how we get rid of that radical. We think about, okay, what's the thing I don't like? Well, I don't like this root 2. And so what you may or may not remember is how can we is that root 2 times root 2? Well, that's the same as root 2 squared. And remember, square rooting something and squaring it undo each other. It's kind of like adding and subtracting. They're opposites, they're inverses. So root 2 times root 2 is the same as saying 2. Okay. And so if that's the case, the way to get rid of this is if I do the same thing to the top and the bottom, I'm going to multiply the top by root 2 and the bottom by root 2. And when I do that, I get 5 times root 2. And then I get root 2 times 2. And remember, from this, we get that equal to 2. Now, when I think about simplifying this, so now we've got rid of the root, but we also have to make sure everything else is simplified. One, I'm going to make sure that there's no radical in the bottom. We did that, check. I'm going to make sure that the root is fully simplified, meaning what we did in the up top, this sort of simplification. If this root was, say, 80, I'd be able to simplify that. It's 2. In this case, I can't simplify it anymore. My third thing that I need to do is I need to simplify my fraction, if I can. So if I simplify my fraction, I'm going to look at this as sometimes this helps people. If I think about 5 over 2, is there a number that goes into both of those? Kind of like 3/6 can be simplified to 1/2. And the answer for this one is no. So I'm going to leave this as 5 root 2 over 2 or 5 over 2 root 2. Both of those are fine answers. And you may argue with me that this looks less simplified than this, and I probably wouldn't argue back because I would somewhat agree with you. It's just the convention of being able to see that this root is up top is what's going to be helpful moving forward. Okay, so there's one. Let's try another one, a little more complicated. We've got a lot more going on, but we're going to start with getting rid of that root. So I look at what I need to get rid of. I need to get rid of the 10, so I'm going to multiply both the top and the bottom by what I want to get rid of. When I do that, this becomes 10, and so I have 5 times 10. And up top, I have this times this times this. 6 root 2 root 10. Okay. And then I can multiply what's inside of the root and I can multiply what's outside of the root. So I'm left with a 6 up top, and 2 times 10 is root 20. The bottom is 5 times 10, which is 50. And so I look at this and I say, okay, so I got the root out of the bottom. Now I'm going to make sure this is fully simplified. So over here, I'm going to simplify 20. And I know that's 4 times 5. Perfect square, 2 root 5. So this is the same as saying root 20. So on here, I can replace that with a root 2 root 5. So I have 6 times 2 root 5, all divided by 50. I'm going to keep combining outside of the root. 6 times 2 is 12. Still have a root 5. And then we have a 50. This is technically all over that. But what I can do is I can think of outside of my root and inside of my root. We already assured ourselves that the inside of the root simplified, but now I can think, thought bubble, 12 over 50. Is there something that goes into both of those? They're both even. I'm going to try that first. I can divide both by 2. When I do that, I get 6 over 25. And then I think, okay, does anything else go into that? And I don't believe that does. So instead of saying 12/50ths, I can say 6/25ths. And then I have my root 5. I can write it like this or like this. Okay.